Hello everyone, my name is Arya Devdar and this is part 4 of NCERT Class 10 Science, Chapter 9, Light, Reflection and Refraction. Okay, so in the last part we completed reflection of light. We ended it with the mirror formula and magnification, right? So in this part we will start with refraction of light. Okay, refraction of light. We'll see refraction through a glass slab, rectangular glass slab. So refraction through a glass slab. So this question is usually asked in the boards. It's a very important question. As well as other than that, it is also like a base case for the refraction to understand refraction of light. Okay. Then we'll study the laws of refraction, right? And then lastly, we'll study the refractive index, which is very, very important regarding your numerical section. Okay, refractive index. Yeah, so let's start with refraction of light. What exactly is refraction? So the definition is big, so I'll just paste it here. It's really big. Yeah, okay. So refraction of light, the like actual scientific definition is when traveling obliquely from one medium to another, the direction of propagation of light changes in the second medium, and this phenomenon it is known as the refraction of light. So what exactly do these sentences mean? Okay, see, for example, we have two mediums. Okay, one medium here, it is air, and the second medium, it is water. Okay, now basically what happens is a light ray enters like this. Okay, at the interface where the two mediums meet. So air is one medium and water is another medium, right? So at its interface, this is the interface, the yellow line. Okay, or at the surface where the two are separated. There the bending of the light ray takes place. The light ray bends, and that bending it is known as refraction of light. Okay, the scientific terms used for bending of light, it is that the direction of propagation of light changes in the second medium. Okay, so it becomes something like this. It does not travel in a straight line, right? We have studied the rectilinear propagation of light. So here, so that was for when the light ray was traveling in one medium. Okay, here the light ray is changing mediums, hence it also changes its direction. Okay, so when traveling obliquely means slant, in a slanting way. Okay, so if it travels perpendicular to the medium, there will be no effect on it. It will go straight through. Okay, it will go straight through. So obliquely from one medium to another, the direction of propagation of light changes in the second medium. This phenomenon it is known as the refraction of light. Okay. Now there are total three cases for refraction of light, and we'll study all of them here. This was a rough diagram. Now you'll see the actual one. Okay. The first case is from rarer to denser medium. Rarer to denser medium. This is the first case. Okay. See, what is a rarer medium and what is a denser medium? Take an example. Rarer is air, denser is glass. Rarer is water, denser is kerosene. Okay, rarer is water, denser is glass. Anyways, okay, so rarer basically means that it has less density. Okay, and denser means it has more density. That is basically the difference between rarer and denser medium. Okay, so here it is saying from rarer to denser medium. So that means if this is air and this is water, and the light ray is traveling like this. So we'll draw a normal at the point where it intersects at the interface, right? And we'll bend it, or it gets bent towards the normal. Remember this, it gets bent towards the normal. So that means when a light ray travels from rarer to denser medium, it bends towards the normal. Towards the normal. I hope you understand what normal is. This is a normal, a perpendicular drawn at the point of intersection of the interface and the light ray. Understood? Okay. So this is the first case. Rarer to denser bends towards the normal. Second case is the exact opposite. Okay. Second case is the exact opposite. I'll do it here. Yeah. Second case. Denser to rarer. Denser to rarer. That means, for example, if this is glass and this is air, and the light ray is traveling like this. ठीक है? We draw a normal at the point of intersection. ठीक है? And we bend the light ray away from the normal. Bend the light ray away. Oh, sorry. Bend light ray away from the normal. Okay. So this is how it works. So basically that means in denser to rarer, the light ray, it bends away from the normal. Away from normal. And the third case, as I explained already, is that when the light ray travels perpendicular to the interface, it does not deviate at all because it is the normal, right? That means that the angle, this angle, it becomes 0. So hence, it goes straight through without any deviation. Understood? Yeah, I'll talk about the angles now. I forgot about that, sorry. Yeah, so this angle, it is known as angle of incidence, I. This angle, it is known as angle of refraction, R. This ray, known as incident ray, right? Incident ray, angle of incidence. This ray, known as refracted ray, okay? And this angle is known as angle of refraction. Understood? Okay, the terminology is very simple, yet I have to explain, right? So these are the three cases for refraction of light. Now moving on. Now this will be very simple for you to understand. Diffraction through a rectangular glass slab. Okay, so that means that this material, it is glass, outside it is air, here also it is air. So first of all, a light ray enters, strikes on the interface like this. A normal is drawn at the point of intersection, right? And the light ray, it bends towards the normal, right? Because this air, it is a rarer medium, glass is a denser medium. Rarer to denser, it bends towards the normal, right? So it will bend towards the normal like this. Okay. So here, this is angle of incidence. This is angle of refraction. Understood? This is normal 1. Now, you have to understand the fact that once refraction happened here, now there will be one more refraction happening here. Okay, one more refraction will be taking place. So here what happens? Now this is glass and this is air. So this is denser and this is rarer. So now denser to rarer. So again we will draw a normal here. Okay, again normal will be drawn. And this time the ray will bend away from the normal. The ray will bend away from the normal. Okay. So in this way. Oh, sorry. Yeah, like this. Okay, so this is how the ray bends. Understood? Okay, because it goes from denser to rarer medium, right? So this is the way the ray bends. Okay. So now, here there are some things you have to understand again. At the second refraction, this angle will again become angle of refraction because the two normals are parallel to each other and this becomes alternate angles, right? So RR, refraction, angle of refraction, angle of refraction. This angle, it is known as angle of emergence. It is known as angle of emergence and it is denoted by the letter E. Angle of emergence and it is denoted by the letter E. Okay, understood? Okay. Now, one more thing has to be noted in this diagram, which is if for example, this incident ray, if I extended it fully, okay, if I extended this incident ray like this, fully, yeah, you'll notice one thing, this ray, this one, it is parallel to this ray. Both rays are parallel to each other. So the emergent ray, this ray is known as the emergent ray. It is parallel to the incident ray, but it has been shifted laterally. Can you understand that? It has been shifted laterally. Okay. So the emergent ray and the incident ray, they are parallel, and the emergent ray has been shifted laterally after two refractions. There have been two refractions, right? Understood? So now you are familiar with refraction of light. Now, with this diagram, refraction of light has become completely clear, I hope. So basically, refraction is the change in the speed of light as it enters from one transparent medium to another transparent medium. Okay, that is basically refraction. Okay, now we'll move on to the laws of refraction. What are the laws? So there are two laws. The first one is same as the law of reflection, the first law. The first law states that the incident and refracted ray, and the normal to the interface of the two transparent media at the point of incidence, they'll all lie in the same plane. You have to write the information about normal. It is at the point of incidence, or it is at the point of the intersection between the interface, right? So you have to write that. I'm not written it. Just remember, okay? So incident ray, refracted ray, and normal, they all lie in the same plane. Simple. That's the first. Now the second one is the most important. The second law. This second law also has a special name given after a scientist. It is also known as the Snell's law of refraction. Snell's law. Okay? Now, what does it state? It states that the ratio of sine of angle of incidence to the sine of angle of refraction, it is a constant. It is a constant. So what does that mean? Ratio. Ratio, you understand? Ratio means sine I is to sine R. That is the way you write ratio, right? It is equal to some constant. It may be anything, but it is a constant value. It does not vary with time or any other factor. It is constant always. But there is a condition. When is it constant? Not always. When is it constant? Or for what type of light it is constant? It is constant for light of a given color. For light of a given color and for the given pair of media. And given pair of media. Okay, understood this much? Right? So now we can also write this statement as in this way: sine I upon sine R. I is incident angle, R is refracted angle, is equal to constant. Now constant, I can take it anything, right? So I'll take it K. Okay, K for constant. So this is the Snell's law of refraction. Okay. So this is the formula. The statement is basically the same thing in words, which I stated at the starting. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for a given pair of media. Okay, so you can write that, I hope so. So now let us move on to something related to this, which is the refractive index. So what exactly is the refractive index? So basically, the refractive index is how much did the light ray change its direction when it when it strike the interface. Okay, how much did it change direction? By what factor did it change direction? That is known as the refractive index in layman language. Okay, so the extent of the change of direction that takes place in a given pair of media, it is expressed in terms of refractive index. Okay, so basically one more way to express it, this K, which I just told you, this K, right, the constant, it is the refractive index. The K, it is the refractive index of a particular pair of media. Okay, so now let me just write down the quick definition of this, right? So what is refractive index? The extent of the change in direction, extent of change in direction that takes place, that takes place in a given pair of media is known as refractive index. Is known as refractive index. Understood? Okay. So now this refractive index you understood. So the first formula for refractive index is sin I upon sin R. So there are total three formulas, you can say, which you have to remember basically. Okay, so the first formula is sin I upon sin R is equal to refractive index. First formula. Okay, refractive index is sometimes denoted as n. It is also denoted as mu. Okay, sometimes denoted as n. Now, moving on to the second formula. Now, this refractive index, it can also be connected to the velocity of light. It can also be connected to the velocity of light. So I'll not go much deep. I'll just directly give you the formula. Otherwise, it will confuse you. Okay. So first of all, you must know this basic knowledge. I hope you already know it. That the speed of light in air or vacuum, speed of light in air or vacuum, it is 3 into 10 raised to 8 meter per second. This is very important. Please make sure you remember this. Okay. So most of you might already know this, but still I have to remind. Okay. Now, moving on to the second formula, which is related to the velocity or speed of light. Okay. What does the second formula state? It says that the refractive index of medium 2 with respect to medium 1. Refractive index of medium 2 with respect to medium 1. Okay. It is equal to the speed of light in medium 1 upon speed of light in medium 2. How to remember this, right? It is very confusing. है ना? Very confusing. ठीक है? Understand this. Here, this is refractive index nu of 2 with respect to 1. 2 with respect to 1. Okay, and then here on this side, what you have to remember कि जिसका refractive index है वो denominator में है. So right? So here the refractive index of 2 with respect to 1, so that means the velocity of 2 is at the denominator. Okay, so you have to remember this in your mind. Mu of 2 with respect to 1 is equal to v1 upon v2. Ulta kar dene ka. Very simple to remember. Now in your textbook, the exact opposite of this is also given as a formula, right? It is given n of 1 with respect to 2 is v of 2 upon v of 1. So don't remember this, only remember 1. So I'll cut this out because it will become very confusing for you. If you remember 1, you'll be able to work out the other, right? So just remember 1. Now moving on to the third formula. The third formula is something called absolute refractive index. Absolute refractive index. So now what is this? Something new? No. Basically here, one medium is fixed. Here both mediums could be different, right? I mean, they are different, but they could be anything. But in absolute refractive index, medium 1 has to be air or vacuum. Medium 1 has to be air or vacuum. Okay. So then the refractive index of medium 2 is considered with respect to medium 1 or air or vacuum. Okay. So that is known as the absolute refractive index of medium 2. Okay. It is represented simply as N2 or mu2. Understood? So that means, for example, here if c is the speed of light, then absolute refractive index N2, I'll just write in green, yeah, N2 will be equal to speed of light in air, c, upon v2. Okay, v2 is velocity of light in medium 2, or you can simply write v. Okay, so this is the formula for refractive index. Here one medium is fixed, medium 1 is fixed, it is air or vacuum. Is this a different formula from the second one? No, the same formula, it's just an application, because here we just write N2. If it was N2 1, that means V1 upon V2, but here V1 is C, so we have written C upon V2. Simple, very simple. Okay, so we just cut the 1 here. It's a different representation basically, nothing else. Okay, so the absolute refractive index of a medium is usually, it is just called a refractive index, or the refractive index of that medium. Okay, so you have to remember the refractive index of air and water. That only those two, nothing else is required, only air and water. Just remember it, it will help you a lot. Okay, in some MCQ questions they directly ask the refractive index of water or the refractive index of air maybe, so it will be easy for you, right? So just remember these two. For air, the refractive index is 1.0003, or which is approximately 1. Okay, and for water, the refractive index is, so water, the refractive index is 1.33, or it is also equal to 4/3. Okay, so remember these two. So we have covered everything in this part. We have covered what is refraction, the refraction through a glass slab, the laws of refraction, and most importantly, refractive index, the 3 important formulas. Okay, so that's it for this part. Thank you so much.